Welcome to another lesson in your favorite math class. Today we're talking about squares, cubes, and roots. And we're going to continue working on being able to answer our essential question of how we can use the order of operations to simplify expressions. Of course, using properties of exponents to simplify numbers is one of those steps. Very important. I'm adding to our vocabulary list for this unit. We're going to be talking today about, of course, I just said squares, cubes, and roots, so we will get into those definitions in our lesson. The squares, you guys should already know this. The square of a number can be found by multiplying that number by itself. That's why we say 3 squared or 3 to the second power, okay? Since it's multiplied twice, it is written with that 3 squared. But wait a minute. Why do we call it squared? A 2 doesn't look much like a square, does it? Well, here's why. We call it squaring because of its shape. A square is very special or unique, you might want to say, because all 4 sides are the same length, okay? Length and width are the same number. So when we find its area, we're actually squaring the number, multiplying it by itself. So the area of that little square there is 3 times 3, or 3 squared, or 9. You guys knew this though, didn't you? Just tell me, what is 13 squared? All right, here's a list. There's 13 squared. But I hope you did it on your calculator and figured it out. I wanted to show it to you, how to do that, and my calculator's hiding behind the slides. I can't seem to grab it. Anyway, we'll do it in class. Here's a list of the first 20 perfect squares. I want you to try to get the first 12 or 13 of them memorized. It'll help you to get through these problems really quick. And you know me, smarter, not harder. So it's smart to have the first 12 or 13 perfect squares memorized. It'll help you so much. Let's talk about cubing. We're going to multiply a number by itself 3 times. That's finding the cube. And of course it would be written with the little 3 there, okay? So why do we call it a cube? Well, same thing as a square. All sides of the cube are the same. So when we find the volume, we're actually multiplying the same number 3 times, which gives us 3 cubed. And I didn't write what the whole volume is, but 3 times 3 is 9. 9 times 3 is 27. So the volume of that cube is 27. Not a hard concept. Just remember, square is 2, cube is 3. And here's a list of the first 12 perfect cubes. Again, you're going to want to memorize some of these, maybe not all 12 of them, but I want to point out to you something, a shortcut here that I want you to be aware of. We've mentioned it in class before. 10 cubed is 1,000. Do you see something going on here? Look at this. The 3 right here. How many zeros? It's the same. That's a shortcut I want you to know, okay? Anytime you see a 10 raised to a power, you can write it out in the long standard, okay, way by just writing down that number of zeros and sticking a 1 in front. That works. But I want you to notice these perfect cubes. 3 cubed, I just talked about, is 27. 5 cubed is 125. Memorize probably the first 8 of them, at least, maybe up to 10, something like that. But it'll help you, again, shorten our work. All right, 13 cubed, what is it? Now, let's talk about taking a root. I'm going to start by talking about the square root. Square root or root, taking a root, is just doing the opposite of squaring. We're undoing. Okay, we're undoing a number. So if you think about it, you already know 3 squared is 9. So if we take the square root of 9 right here, we get 3. It's as simple. It's just going backwards. Just doing and undoing. We're just doing and undoing. Okay, now we call it a perfect square because it ends up with a whole number. So 9 is considered a perfect square because when we take the square root, we get 3, a whole number. But 10, which is so close to 9, but it's not quite there, if we put that into our calculator, we don't get a perfect whole number. We get a decimal, 3.16, okay? So it's not a whole number. 10 is not considered a perfect square. So what's the deal with finding a square root? Well, let's talk about the square root of 16. Here's what I want you to think about, other than when you're typing it in the calculator, okay? The thought process would be, what number times itself, or squared, will give me 16? 4 will, of course. Therefore, the square root of 16 is 4. Now, I want you to notice something. I've got up here, that looks a little different than that one here. That one looks mostly like a check mark, and this one actually has like a roof over its head. You will see it both ways. I use it interchangeably. Sometimes if I copy something and it's shown this way, I'll just leave it that way. My favorite is like this, so if you see me write it by hand, you're going to see a roof, okay? And a lot of times I'll change it to have a roof. But it doesn't matter, whichever way, okay? I don't want you to panic. So, after all that chat, what's the square root of 81? What number times itself will give me 81? It's a perfect square. And believe it or not, it's 9. I hope you thought of that on your own. One more. What is the square root of 36? Think hard. You can do this. Don't use a calculator. Think, 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 think. It's 6. 6 times 6 is 36. Not hard, right? Well, especially if you have this chart around, which really makes it nice for the perfect squares, the perfect cubes. All right. What I've shown you here is the first 12 perfect squares and square roots. Notice something there. I have a lot in common. If you know one of these, you know the other one. 11 squared is 121. The square root of 121 is 11. It's not so hard. It looks like a lot of information, but it's really not. If you learn this one, you know this one. Now look at the perfect cubes. All right. If you know this one, you know this one. Okay. And as you can see, I kind of had to piece it together. I couldn't find one with all 4 things. And I wanted to show them side by side. So that was the best I could do. I do have this as a help sheet for you. So you can have this printed out, stick it in your notebook, have it handy when you're working. It'll help as you memorize the perfect squares and some of those perfect cubes. All right, take the square root of 196 for me. Now take the cube root of 2197. Notice the reason I'm saying cube root is there's a 3 here. We'll talk more about that in a minute. All right, number 5, another cube root. So did you notice square roots, most of the time, you won't see a number here. So if we see a root symbol and you don't see a number, you're taking the square root of it. If you see a root symbol, that's the root we're talking about. That's the root we're taking of it. So far, all we talked about are squares, square roots, and cube roots, though. Okay. Someday, not real soon, we're going to talk about higher ones there. Woof. That's for another day. We don't need to worry about it today. Okay, so your reflection question is a little different today. I don't want you to tell me how you feel, although you can. But think about it. Remember I mentioned before, I gave you that chart, and you can look. What number is a perfect square and a perfect cube? Find a number, look at that chart, but then don't tell me you know because you looked at my chart. Just show me how to do it. Show me what a square of a number is. Show me what the square or what the cube is. Okay? The cube root and the square root. I want you to explain it or show me. Well, thanks for watching. As you know, we're learning all about squares and cubes and roots and stuff. And oh, next lesson, quotients as fractions. How do they relate? Oh no! See you next time.